Download this code from codegive.com, link in the description below. Pressure Testing Practices Part 2, Building a Robust Load Testing Framework with Code Examples. This tutorial builds upon the foundational concepts of pressure testing introduced in Part 1. We'll dive into building a more robust load testing framework, focusing on practical code examples, advanced configurations, and best practices for analyzing and interpreting your results. Recap from Part 1 Asterisk. What is pressure testing, load testing, stress testing, endurance testing, understanding the different types of performance testing and their goals. Why is pressure testing important? Identifying bottlenecks, ensuring scalability, and preventing failures under stress. Key metrics to monitor. Response time, throughput, error rate, resource utilization, CPU, memory, network I/O. Basic tools. JMeter, Gatling, Locust, K6. Part 2, Building a Load Testing Framework. In this section, we'll focus on building a framework using Python and Locust, a powerful and scalable open-source load testing tool. We'll cover 1. Installation and setup. Installing Locust and necessary dependencies. 2. Defining user behavior. Creating Locust tasks to simulate user interactions. 3. Configuring test scenarios. Setting up ramp-up periods, user concurrency, and test duration. 4. Monitoring and reporting. Integrating with monitoring tools and analyzing test results. 5. Advanced features. Parameterization, data injection, and external data sources. 6. Best practices. Designing realistic scenarios, handling dynamic data, and managing dependencies. 1. Installation and setup, Locust. First, ensure you have Python installed, version 3.7 or higher recommended. Then, install Locust using pip. You might also need to install additional dependencies depending on your target application's authentication or data format requirements. For example, if your application uses OAuth 2, you might need the request-so-auth-lib library. 2. Defining user behavior, Locust tasks. Locust uses Python to define user behavior through task sets and HTTP user classes. Let's create a simple example that simulates users browsing a hypothetical e-commerce site. Explanation. HTTP user the base class for Locust users. It defines the host, your application's URL, and wait_time, the time users wait between performing tasks. Task set organizes related tasks. Browse products task set and add to cart task set represent different user behaviors. At task decorator that marks a method as a task to be executed by the user. The number in parentheses is the task wait. Higher wait means the task is executed more frequently. Self.client an instance of Locust's HTTP client, used to make requests to your application. Self.client.get, and self.client.post, methods for making get and post requests, respectively. The name parameter provides a descriptive name for the request, which is used in Locust's reports. Between 1, 3, specifies a random wait time between 1 and 3 seconds. This simulates more realistic user behavior. On_start, a method that is executed when the user starts its journey. Useful for tasks like login. It gets called for each simulated user when it begins its life cycle. We're initializing a random_product_ids list here within the Locust environment so all task sets can share a list of product ids and ensure there's always a product ID available. Important note, This is for demonstration. In a real-world application, you would likely need a more sophisticated mechanism for managing product IDs, potentially fetching them from an API endpoint or a database. *on_stop, * a method that is executed when the user stops its journey. Useful for tasks like logout. 3. Configuring test scenarios. To run the load test, save the code above as locustfile.py, or any name you prefer, and run the following command in your terminal. This will start the Locust web UI in your browser, usually at http://localhost 8089. From the UI, you can configure the following. *number of users * the total number of simulated users to spawn. *hatch rate * the number of users to spawn per second. This controls the ramp-up speed of the test. *host * the target host, your application's URL. This can also be set in the locustfile.py. *runtime * the duration of the test. Example configuration **** number of users * 100. *hatch rate * 10. *host * http://localhost 8000. *runtime * 600 seconds. This configuration will simulate 100 users, ramped up at a rate of 10 users per second, and the test will run for 10 minutes. 4. Monitoring and reporting. Locust provides a real-time web UI that displays key metrics during the test, including *requests per second, RPs the number of requests your application is handling per second. *response times * the average, minimum, and maximum response times for different requests. *failures * the number of failed requests. Integrating with external monitoring tools, optional. For more detailed monitoring, you can integrate Locust with external monitoring tools like Prometheus and Grafana. This allows you to track system-level metrics like CPU usage, memory consumption, and network I/O. *Prometheus * a time series database that collects and stores metrics. *Grafana * a data visualization tool that can display metrics from Prometheus, or other data sources. Locust provides a built-in event system that allows you to export metrics to Prometheus. You'll need to install the Prometheus client library. Then, add the following code to your locustfile.py. Then, you need to expose the Prometheus metrics endpoint. You can do this by running a simple HTTP server that serves the metrics. A full Prometheus and Grafana configuration and deployment is beyond the scope of this tutorial, but you'd typically install Prometheus and configure it to scrape the Locust master. Locust has built-in integration for sending these metrics. Analyzing test results ***. Identify bottlenecks ***. Look for requests with high response times or high failure rates. These are potential bottlenecks in your application. Correlate metrics correlate performance metrics with system-level metrics, CPU, memory, network I/O, to understand the root cause of performance issues. For example, high CPU usage on your database server could indicate a database query performance problem. Track trends run load tests regularly and track trends over time to identify performance regressions. 5. Advanced features. Parameterization use variables in your requests to simulate different user inputs. For example, you can use a list of product IDs to randomly select a product to view. Data injection, using CSV files load data from CSV files to simulate more realistic user behavior. For example, you can load a list of usernames and passwords from a CSV file to simulate user logins. External data sources, databases, APIs fetch data from external data sources to simulate more dynamic and realistic scenarios. 6. Best practices. Design realistic scenarios. Simulate real user behavior as closely as possible. Analyze your application's usage patterns and create tasks that reflect those patterns. Handle dynamic data. Use parameterization and data injection to simulate different user inputs and data. Manage dependencies. Ensure that your load testing environment is properly configured and that all dependencies are available. Start small, scale up. Start with a small number of users and gradually increase the load until you reach your target concurrency. Isolate your environment. Ideally, run your load tests in a separate environment that is isolated from your production environment. This prevents the load tests from affecting your real users. Automate tests. Integrate your load tests into your continuous integration / continuous delivery CI/CD pipeline to automatically run tests on every code change. Monitor everything. Monitor your application and infrastructure during the load tests to identify potential bottlenecks and performance issues. Example: complete locust file with CSV data injection. Example CSV files, place these in the same directory as your locust file. Product_catalog.csv*. Search_terms.csv*. Running the example *1. Create the locust file.py, product_catalog.csv, and search_terms.csv files in the same directory. 2. Install locust, pip install locust. 3. Run locust, locust locust file.py. 4. Open the locust web UI in your browser, usually http://localhost 8089. 5. Start the load test. This example provides a foundation for building more complex load testing scenarios using Locust and Python. Remember to adapt these examples to your specific application and requirements. Good luck.